Hi, welcome to another video in this video series for General Maths, Mathematics 1. In this particular video, we'll look at a couple of problems that has to do with polynomials and how to manipulate, find the factors, how to determine whether a polynomial has a factor or not, as well as how to do polynomial long division. Okay, so let's just get started. Now, in this first problem, a couple of things that you have to know in order to be able to find whether a particular polynomial is a factor of another polynomial. What you need to know is what we call the remainder theorem. Right. Now, what this theorem basically says is if I have a polynomial p of x, which is called the dividend, and then we have another polynomial q of x. So let's say d of x, call the divisor. Then if d of x divides p of x completely, then it implies that what d of x is a factor of p of x. But what does it mean to say that a polynomial d of x divides another polynomial completely? It means this basically means the remainder is 0. That's what it means. Because we can write p of x as what? When d of x divides p of x, we'll have what we call the quotient, right? Times that divisor plus the remainder, right? Now, when this remainder is 0, we say that what d of x is just is a factor of what p of x, right? That's what it means. Okay, now what does the remainder theorem say? The remainder theorem says that, okay, and this is generally true for when you have a divisor. So when you have a divisor that is in this format, ax plus b, that's a linear factor, basically a linear polynomial. Now when you have such divisor, it says that if I can equate this to 0, whatever this x is, so this will now be minus b over a. It says that the original polynomial, when I substitute this b minus b over a into this polynomial, this would give me the remainder of that division. Now, that's how we can find the remainder. And when this remainder is 0, that means that what d of x would be a factor of this p of x, right? So that's what we're going to use to solve this problem. So let's get started on it. Now, so we're looking at the first problem now. So 1a. So we have this polynomial f of x, which is minus 2x cubed minus x squared plus 4x plus 3. Now, if x plus 1 is a factor, so this is the divisor, right? D of x. If x plus 1 is a divisor, is a factor of f of x, what must be true? The remainder when when f of x is divided by x plus 1 is 0, right? So this is what we need to figure out. Is this actually 0? And we're going to use the remainder theorem to do this. So by the remainder theorem, of course, we need to first of all make x plus 1 equal to 0, which gives us x equal to minus 1. And then what we'll now do is we need to find f of minus 1. And if this gives us 0, it means the remainder when f of x is divided by x plus 1 would be 0. So so f of minus 1, let's figure this thing out. So this is minus 2 minus 1 raised to power 3 minus 1 square plus 4 times minus 1 plus 3. And this would give us, this is minus 1, this will give us 2, and this will give us minus 1, and there's minus 4 plus 3. So this basically gives us 5 minus 5, which is 0. So as you can see, the remainder is 0. Okay, so because of that, we can conclude that what x plus 1 or we can conclude that what f of x is divisible by x plus 1. Another way, this means that what x plus 1 is a factor of f of x. And now what does this mean? It means we can actually write f of x as x plus 1 times another polynomial q of x. Remember, the remainder must be 0, right? So we can just forget about this part. It means we can actually write f of x as what? X plus 1 times another polynomial q of x. And once you do the long division, you can actually get what q of x is. So this is a simple way of figuring out the factors of a particular polynomial by basically looking for what numbers that we can substitute into the polynomial that will give us 0 remainder. Okay. Now that we have this, let's look at the next one. So x plus 1 is a factor of f of x. How about x minus 1? So we do the same thing. So for x minus 1, we need to also equate this this divisor to 0, and this will give us x equal to 1. Then we have to find f of 1, right? When we do this, the same in the same polynomial, so this will give us this particular expression. So this will give us minus 2 minus 1 plus 4 plus 3, and as you can see, this is minus 3. This will minus 3 plus 4 plus 3, that will give us plus 4. This is not equal to 0. Because of this, it means x minus 1 is not a factor of f of x. And what does that mean again? It means that what we can write f of x as what? This x minus 1 times another polynomial q of x plus this remainder, which is actually 4. This is what it means. We can write this initial polynomial this way, right? So that makes sense. That's the solution to that particular problem. Okay, now what about the second part? So let's move to the second part. The second part is actually how we can find polynomial. We can do polynomial long division. Okay, so this is the best way to approach it. Now, depending on the country you're from, this can actually change. I know that in Turkey they use a different version of this, but here in Nigeria, this is the way we structure this, where the dividend, which is the main polynomial we're trying to divide, is this, would come inside the square root, if you might say, and outside the square root we have the divisor. And up here we are going to have the quotient, and down here we are going to have the remainder. Basically, this is how it works. Now, how do we do polynomial long division? So what we do is we take the first of this term here, and that's what you're going to do throughout this division. The first term here to go into the first term here, right? The highest polynomial degree. Okay. In case we have switch of terms where, for example, let's say this was how the problem was given to you, you will have to rearrange to make sure that what the highest polynomial comes first, the highest degree comes first, right? So you have to rearrange, right? Just a side note. Now we say that what x into x cubed, that's the first step. So basically we are saying x into x cubed. So you're saying x cubed divided by x. That's what we mean by x going into x cubed. Now this will give us x squared, right? Using indices, this is going to be x raised to the power 3 minus 1, which is x squared. Okay. Now the next step is we'll now multiply this with this term, right? So the first one will be x squared times x. That will give us x cubed. The next one will be x squared times 2, which is plus 2x squared. Now at this stage you subtract. Now you make sure that you put bracket around this term so that you don't make sign mistakes. Most students would make sign mistakes, right? So, and you're not one of those students, so what you do is you put bracket around this. Now we subtract this polynomial from the polynomial we started with. So how does this work? X cubed minus x cubed, that will be 0. Now the next one is minus 7x squared, minus times plus is minus, so minus 7x squared minus 2x squared, that will give us minus 9x squared. Then that we are done with this, so we write out the remaining terms. We bring down the remaining terms, which is minus 13x plus 15. Okay, so we continue. So the next one, again, this is one full cycle. The next step is we divide, we go again, right? So we'll do the same thing again. X now going into minus 9x squared, right? And what would that give us? So basically minus 9x squared divided by x, and that is minus 9x. So the next one will be minus 9x, the next term in the quotient. Now we'll multiply. Minus 9x times x, that will give us minus 9x squared. Now, if you get this one correctly, you always know the first term that would come here. You always know this is going to be the same thing as this if you do the division properly, right? So that can mentally help you to do this problem faster. So minus 9x times x, you have minus 9x squared. Then the next one will be minus 9x times 2, that will be minus 18x. Again, you subtract, right? And don't forget your bracket, okay? You subtract and don't forget your bracket. So let's do the subtraction. Now, because you got this one correctly, you always know that when you subtract this term from this term, it's going to give us 0. As you can see, minus 9x squared plus 9x squared, that would be 0. Then the next one will be minus 13x plus 18x. Minus 13x plus 18x, that is 5x. And finally, we bring this term here because there's nothing to subtract it from, or there's nothing to subtract from 15. So we have plus 15. Okay. So what happens finally? Finally, we come to the last stage. Again, x into 5x, that would give us what? Plus 5. So 5 times x is 5x. 5 times 2 is what? 10. Then we subtract again, and that will give us 0. 15 minus 10, that is what? 5 plus 5. So this means that what? Our initial polynomial, this means this is the quotient. This is the quotient q of x, and this is the remainder r. Okay, so which means that the initial polynomial, which is the dividend, can be written as the divisor multiplied by the quotient plus the remainder, right? Plus the remainder. Okay, so so this is the polynomial long division, right? That is how we solve the problem. Now we're going to look at the second one, and we're going to move much faster here because now you understand the process. So let's set it up. The problem says 2x raised to the power 5 minus 6x cubed minus 14x divided by what? X minus 2. Now, again, the first thing, x goes into 2x raised to the power 5. That will give us 2x raised to the power 4. Now, 2x raised to the power 4 multiplying this. So 2x raised to the power 4 multiplied by x, that's 2x raised to the power 5. And 2x raised to the power 4 multiplied by minus 2, that's minus 4x raised to the power 4. Then we take subtraction. Now, this is where many students also make mistakes. Now, notice that when you subtract this, 2x raised to the power 5 minus 2x raised to the power, that is 0. Now, the next power, notice that there's no x raised to the power 4 here, right? Which means we only have x raised to the power 4 down here, right? So we just have to simplify this expression and just write out what we have. So minus times minus 4x raised to the power 4, that will give us 4x raised to the power 4, okay? Not minding the fact that we don't have x raised to the power 4 up here, okay? Now, what is next? X raised to the power 3. So what was that? Minus 6x raised to the power 3. So we'll bring out the rest of the terms that do not have any other common term down here. So this will be minus 6x raised to the power 3, then minus 14x. All right, cool. So what's next? Again, do the division. X into 4x raised to the power 4, that will be plus 4x raised to the power 3. This times x minus 2. So 4x cubed times x, we have 4x raised to the power 4. 4x cubed times minus 2, that's minus 8x raised to the power 3. And then we subtract. Now, the 4x raised to the power 4 minus 4x raised to the power 4, that's 0. Then the next one, minus 6x raised to the power 3, minus, that will become plus 8x raised to the power 3. That will be 8x raised to the power 3 minus 6x raised to the power 3. That will give you 2x raised to the power 3. Then we have minus 14x. We'll bring this thing down here again. Then we continue. X into 2x raised to the power 3, that will be what? Plus 2x squared. So 2x squared So if you're wondering how I got 2x squared, it's basically this divided by x. So that will be squared, 2x squared. So 2x squared times x, that will be 2x cubed. Then 2x squared times minus 2, that will be minus 4x squared. Then we subtract again. You see, this can get quite long, right? But you have to be patient till the end. Now 2x cubed minus 2x cubed, that is 0. Again, we have that similar problem that we had here. Okay, so minus times minus 4x squared, that will give us 4x squared. Then we still have minus 14x here. Okay, then again, x into 4x squared, that will be plus 4x. Now 4x times x, that is 4x squared. 4x squared times minus 2, that's minus 8x. Then we subtract again. So 4x squared minus 4x squared is 0. Minus 40x plus 8x, that will be minus 6x, right? That's what we have. Then again, one last time, x into minus 6x, that's minus 6. Minus 6 times x, that's minus 6x. So that we can see everything. Minus 6x, then minus 6 times minus 2, that is plus 12. Then we take subtraction again. Now, when you subtract this, the first term would go away. Minus 6 plus 6 is 0. Then minus times plus 12, that's minus 12. So this will become the remainder. So we have to stop when the degree of this polynomial is less than the degree of this one, right? And degree of this one is 1, degree of this one is 0. So we have to stop now. Okay, so this will be the remainder, which means the original problem, the dividend can be written as what? The divisor multiplied by the quotient. The quotient is quite long. Then plus the remainder, which is minus 12. So this is the solution to the problem. Okay, the last one, right? Make sure you try your hands on similar problems somewhere, right? So just find on the internet, try your hands on other problems of similar nature, and just really get very good at this, right? So make sure you like, comment down below type of videos. You have any specific question that you want me to look at, please make sure you do send your request, and also share this in your social media, share this among your friends so that they can also learn from this channel, and make sure you subscribe to the channel as well, so that you can help the growth of this channel. So thank you very much for staying till the end of the video, and I'll see you in the next one.